Thank you. So this talk is from Mauricio Gruppi, Benjamin Horne, and Sibel Lavalley. So the name of the paper is Tell Me Who Your Friends Are Using Content Sharing Behavior for News Source Veracity Detection. So I believe Benjamin will present the work, right? Exactly.
Yes, I will. Yep. Let me just share my screen real quick.
Yes, thank you. So Benjamin is an assistant prof at the University of Tennessee, Knoxville, and stage is yours.
Great, perfect. Thanks for the introduction. So my name is Ben Horne. As was stated, I'm an assistant professor at the University of Tennessee. This is group work with my colleagues at Rensselaer Polytechnic Institute and something we've been working on for quite some time. There's a lot of technical details I'm going to have to sort of gloss over in this time, but please feel free to ask me questions. So the main question we ask in this paper is, can we automatically detect when a news article comes from an unreliable source? And you may be thinking that's not a very unique question. Many people have asked that, and that's true. There's tons of related work over the past 5 to 6 years asking this same question or related questions. And long story short, the majority of works in this area focused on categorizing news articles using the text. So given a news article features on the text of that article, can I predict if it comes from a bad or a good source? And we've sort of seen mixed results from these works. So on one hand, we do have some accuracy, right? We can predict with accuracies ranging from 70% to 90% if an article comes from an unreliable source. But we also have problems with things like concept drift. As topics change over time, so does the feature space. So there's many different issues in using text of the news articles. And so in this paper, we want to ask, instead of using text features on the articles, can we use some behavior about the actual news source? Because most of the time when you're given a news article, you're also given the source in which it comes from. And this has also been done to some extent, right? So things like how have news sources behaved on Twitter? Do they have a Wikipedia page? There's many different signals that have been used at this level. What we want to use is a thing called content sharing. So this is where one news producer publishes or copies an article from another news source. And this is something that you probably recognize as syndication in mainstream media, right? ABC News syndicates news from Reuters or AP News. This is very common. However, in malicious news sources can be sort of a tactic to make news seem more important, more credible, more widely reported, even if it actually is not. And there's been several previous studies that have shown that this is actually a meaningful tactic. In particular, these two past ICWSM studies, in both of them showed that if you form this copying behavior as a network, you can actually get out some meaningful structure. And for the sake of time, I won't talk about how to construct the networks, but they're actually quite simple. It's basically TF-IDF over a bunch of different news articles, and then you sort of use some heuristics to tell which direction they're being copied from. And in both these cases, networks are formed from that analysis. And what you'll see here are two networks where the nodes are the news sources. The size of the node is how much that news source is being copied from. And then the colors are communities or clusters of news sources that are copying from each other. And in both studies, to some extent, there has been shown that these communities actually represent distinct parts of the media ecosystem. So very quickly, as an example, in this network from previous work, the yellow community is sort of right-wing conspiracy. You have sources like InfoWars, TruePundit. The orange community is Russian conspiracy. So you have RT, Sputnik, several different state actors, along with some other conspiracy news sources. And then you have other communities that represent mainstream news in different countries. Long story short, the structure here is not just something pretty to look at. There's actually some rich details being stuck in this network. And so can we utilize this rich structure to actually detect when a news article comes from a bad source? So to do this, we do two things in this paper. First, we create handcrafted network features, which I won't get to talk about today. The basic idea is things like centrality, what community does the news source fall in, etc. And then the second thing, which you'll see works a little bit better, is to embed that network and use that as the feature for each source. So to embed this network, we're going to use Node2Vec. Many of you are probably very familiar with this. This is sort of the ingenious layer on top of Word2Vec to embed network spaces, just like we embed words in some sort of document. So very quickly, if you don't know how Node2Vec works, the idea is very simple. We have our network space, which in this case is our copying network. We're going to take random walks over this copying network. And as we take these random walks, we're going to record our path. And we do this over and over and over again until we get something that looks kind of like a text document. We can then pass that into a word embedding model like Word2Vec. And now we get these dense vectors that represent each node. And in this case, each of these dense vectors represents where a news source is in this content sharing space. And so now we have a feature vector for each news source, and we can set up a classic machine learning model. So in this case, just like with any other study in this area, we have two groups: reliable sources, unreliable sources. This is from NewsGuard ratings, but there's a number of different ratings you could use to create these groups. Given a news article from an unknown source, our goal is to predict if that source is reliable or not using this feature vector. The most important thing to talk about in this setup is that we're doing source splits. So in most of these setups, when you're using articles, you just do sort of a split on the articles randomly, 80-20. In this case, we're splitting on the sources. So if I say that Reuters is in the test set, I'm taking all articles from Reuters out of the training set, and those are in the test set. So these are two very separate things. So you're not getting any sort of ground truth leaking into the algorithm. And so very quickly, we find that the content sharing networks actually improve accuracy quite a bit over a couple different text baselines. So these text baselines are the same exact setup, except for now we're using feature vectors from the individual articles. And so one is a word embedding model. Fast text, we've also used BERT. It doesn't show much different. And then the other is NELA, which is handcrafted features. Against both of our different feature vectors for the network space, you'll see that there's some improvement, most significantly being when we use Node2Vec. Now, one thing you're probably thinking, there is a problem here, and that is if a source never copies an article and just writes all original pieces, then we actually can't represent it in this content sharing network. And so to mitigate this problem, we're going to combine the text features at the article level with the content sharing network features at the network level. And there's a bunch of ways we do this, but the sort of novel way we do this is through a multi-scale attribute network embedding, and this is where Mauricio sort of did all the heavy lifting, so I'm talking for him here. The basic idea is that, again, we're going to embed the network space, but now we have two networks. We have the content sharing network, and we have this word embedding network in which nodes are still news sources, but now they are distanced from each other's Euclidean distance in this word embedding space. And the node is just an average of all articles, word embedded vectors. So now you can sort of say, if I have a news source that's never copied before, I can say roughly, who does it look most like? And we're going to do the same thing. We're going to do random walks over all these networks with some parameter of which network we're going to do a random walk over, eventually getting this big document of how these sources relate to one another in both the spaces, pass it back through a word embedding, and we get these dense vectors back. And so this actually improves our situation, not only in accuracy, but also that if a news source never copies, we can now represent it through its word embedding space. And so, again, I'm showing you text features, network features, and then the different combinations. You can see we can do very simple things like adding the vectors together, et cetera. But this multi-attribute network embedding actually gets the best accuracy. Now, very quickly to end, this isn't just arbitrarily getting higher accuracy. It's actually very important to note that the models are making dissimilar mistakes. And I can show this to you in two ways. The first way is the probability that one model, a text model, is corrected by the other model, a network model, and then also the distribution of errors on each class. So what you'll see here is if I'm using the handcrafted text features and they make a mistake, there's a 90% chance that that mistake is corrected by the multi-attribute network embedding. And then vice versa. If I have a mistake made by the network features, it has a 49% chance of being corrected by the text features. You can also see that over here with the different classes. So we see that text features are making fewer mistakes on the reliable class, while the network features are making fewer mistakes on the unreliable class. And there's two very good reasons for this. In the writing space, we have very, very consistent writing styles from mainstream news sources, which are falling into this reliable class. Because they're trained journalists, this sort of makes sense, right? They're consistently writing with the same style, whereas in the unreliable case, the styles are sort of all over the place. So we have a wider range of feature vectors. And then in the network space, we have a similar thing. So you'll see that all of the sort of conspiracy sources that are labeled unreliable are in a tight cluster, whereas the mainstream news sources that are in the reliable class are in a very spread out cluster and are also copied from a lot of unreliable sources. And so their feature vectors in the network space are thus more spread out in this high dimensional feature space. And so pros and cons, this network method is highly accurate. It's robust to concept drift without doing any sort of retraining because the sources stay pretty consistent. We think it's explainable, but we need to sort of test that on users. Cons, we still must use the article text if a source is never copied before. And we've also found that investigative journalism is not well captured because they're mostly original news articles that are not being copied throughout this space. So I think I made it within my 10-minute limit here. Happy to take any questions.